Hi, and welcome to episode 11 of Johnny Does .NET. My name is Johnny Hooibergs, and in this series of videos I will talk about my favorite programming platform, .NET. In this episode I will talk about the template worker service, and with worker service we can create an application that does background processing without any user interface or any user interaction. If we want to create a worker service, we can do it from Visual Studio or from the .NET command line interface. I'm going to use Visual Studio for now, create a new project, and use the keyword worker to find the template for creating worker services. You can see that's very easy. I only have two results, one for C#, so I'm going to pick the C# .NET worker service. I'm going to select next. I'm just going to put it in the regular directory with just the random name worker service 1, which is fine. And I'm going to use the latest .NET version, .NET 6, as of today. So I'm creating this project, and while Visual Studio initializes my worker service project, I will again explain to you what a worker service is. So a worker service is an application without a user interface or any user interaction that can run in the background and can perform all kinds of tasks invisible to an actual user. If you look at Windows specifically, you have what is called the service management window, and within this services management window you can see a lot of already running and available Windows services. So these are actually worker services or Windows services that perform some kind of background task, and they perform it while your computer is running, invisible to you as an end user. So with a worker service, we are going to try to do the same thing. We are creating a piece of code, we are writing a piece of code to create an application invisible to the user that performs some long-running operations in the background. In practice, you can actually create an application, for example, that sends an email to a user every hour, if you would want that. Or you can create applications that run in the background that do some cleanup of your data, for example, or that look at all of your pictures and then they create little thumbnails of all of your pictures. So you need to be creative, and you need to find a way of, okay, what things do I need to do in the background, which a user does not really need to give any input for, and I need to put that inside of a worker service. So now that Visual Studio has finished creating my application, you can see that again the structure is very straightforward. It's the same as all the other .NET templates, and we have that program.cs to start up and configure my application. And in this case you can see that we are using a host builder, another web host builder, because of course we are not creating a web application, we are creating a hosted service or a worker service. Within the services that are configured, we are actually initializing a hosted service. And a hosted service is a class that performs some kind of task for us in like a long-running fashion. So the worker class you can actually also find prepared within this project template, and it is a class that derives from the background service base class, and the background service base class provides us with all of the functionality needed to create long-running background services and has support for Windows services, for example. This class has an execute async method which gets overridden from the base class, and within this overridden execute async method we can write our own logic to perform a long-running operation. And in order for my application to actually be long-running, it needs to have some kind of loop, maybe an infinite loop that continuously loops and does something for us. Now, if you are, for example, creating thumbnails for multiple pictures in a folder, this loop would actually loop through all of the images, and each image for each image, it can then create a thumbnail, for example. And when it reaches the end, it can start all over, because maybe you have added some images throughout that time that it was busy creating the thumbnails for the already existing images. So this is just an example of what a long-running service can be. In this demo application, the code that's been generated for us just logs a piece of information every second. Why every second? Because it will basically wait for 1000 milliseconds, so 1 second, and then it will continue with that while loop. And then again, it will log some information, it will wait for 1 second, and then again, it does the same thing. So just to make things a little interesting, I'm going to change this to log warning. And we are logging this piece of text and the current time each second. Now, we can run this from Visual Studio, not as a Windows service, but as a console application. A worker service is just a template that is creating a long-running application for us, but we can run it as a console application, which is very cool for testing, because now we can see an output. We have some user interaction here. I can see the console that is basically showing me all of these warnings that get logged every second with the current time. So I know that my service is working, and I can debug the service that I'm working on. Now, you can also see that the while loop is continuously looping while the cancellation token has not been cancelled, or a cancellation request has not been fired. So the cancellation token is actually an object that an external party can manipulate to actually cancel it or request a cancellation, and based on that I can do something. So if a cancellation token has been cancelled or a cancellation has been requested, I can actually finish my current work because I'm inside of the loop. I can finish whatever I'm doing, again with the example of creating thumbnails for images. I can finish creating my current thumbnail, I can store it to disk, and then when I'm finished, the while loop will not continue because my cancellation has been requested from an external party, which basically makes my service stop, because when you leave this execute async method, your service, your long-running service, will automatically come to an end, and you need to restart it manually or by using some kind of script. This is actually something that we do in Windows services. If you right-click a Windows service, you can start it, but if you right-click an already running Windows service, you can stop it. So you can start and stop services manually from that services management console, or you can of course do it using scripts if you want. Now, of course, there's still a difference, because here I am writing a worker service, and when I test it, it runs as a console application. And here I can install a service as a Windows service, or a worker as a Windows service. So I need some way to actually make that happen. And I told you already before, in .NET we can actually install some additional packages or additional dependencies that will provide some extra to our applications. So I can actually find a package, Microsoft.extensions.hosting.windows, and this package is specifically used for making your worker service compatible to a Windows service. So if you install this, you basically add some functionality that you now can use to make your worker service compatible with a Windows service. In order to do that, you need one more step, and that is inside of your program.cs, where you do program startup and program configuration. You add one single line of code that says use Windows service. And this way you add the necessary code to actually make sure that when a user installs your application as a Windows service, that it can also stop and start that service from the management console or from a script, and that this actually translates to your worker execute async method and the cancellation token that is residing within. So I did this. I run my application, and it runs just fine as a console. How do I install it as a Windows service? In order to do this, you need to go to your console or to your terminal. You need to find your worker service binary files. So that will be the worker service project, then the bin folder, then the debug folder, then the net6 folder, and inside of this folder we should have our compiled executable for my worker service. Again, I can just run my worker service from here, but then it just runs as a console application. If I want to install it as a Windows service, I need to use some utility to do that. And the utility that I can use is sc.exe. sc.exe is an application that I can use to actually do operations on a Windows service. So I can, for example, do create my Windows service, which is the name of the service, space, and the binary path will be equal to the path that points to my binary executable file. So I can go up and find the current directory, and then the name of the actual executable. Maybe I can do it like this, .exe. There we go. When I execute this command, I get a response, create service was a success. So I know that my service has been installed successfully. So if I look at my services management console, I refresh, I should be able to find my Windows service. And here it is. It is not running, and it is set to startup manual. I can change this in the properties. I can change the startup type to automatic, which means that when my Windows platform starts, my Windows operating system starts, my service automatically starts with that. I could also do a delayed start when I want to make it start a little bit later and not immediately in the beginning, or I can just leave it at manual, which means that I need to start it manually or another service needs to start it manually. I can now right click and click start, which will make my service run. And now it will run indefinitely. It will every second show me that warning message, or at least it will not show me because there's no user interaction, there's no user interface. It is just running in the background, consuming some CPU cycles to actually log something to somewhere. What is somewhere? Well, inside of Windows, you also have access to the event viewer. And the event viewer shows you these logging messages from all of the different applications on your operating system that are installed within your operating system. So here you can indeed see that I have my worker service 1 running, and that my worker is running at this time. So every second it will log that warning message because I used the logger.log warning. So here I can see the result. Again, only when you search for it within the event viewer, you can find this. Otherwise, your application just runs silently in the background without anyone knowing, performing background tasks as much as it wants. Now, this is how it works on Windows, because .NET is a platform-independent platform or technology. You can do the same thing on different operating systems, if of course the operating system supports that kind of long-running background service. And for example, Linux actually supports something very similar to a Windows service. In Linux, we have the concept called systemd, and this concept is able to run services or run daemons. So let's go to my Linux environment. Let's log into my Ubuntu Linux distribution, and let's create again a new worker project, but now install it as a service on Linux instead of as a service on Windows. So I'm going to create a directory called my Linux daemon. I'm going to go inside of this directory, and I'm going to use .NET new worker to create a new .NET worker based on that template. So, sorry, this is my project. I'm going to open it in Visual Studio Code, which will make my life a little bit easier. So sources, my Linux daemon, open. Again, we know it's the program.cs, it's the worker service, and I'm just going to make a small change. And let's say we log not information, but again, warning. Now, as you know, you can still run this as a console application inside of my terminal. So I can do .NET run. It will build and it will run this worker service just fine, but in the console. And now it will warn, it will log that warning every second. Perfect. Now, I want to do the same thing as on Windows. I want to make it compatible with not a Windows service, but systemd daemons. So inside of my project, I can also add that dependency. In Visual Studio, I used the manage NuGet packages to do this, but actually I know the name of the package by heart. So I can just copy paste this little line of code right here, because I'm going to include the Microsoft extensions.hosting.systemd package, which has 6.0.0 as its latest version. Of course, I know this by heart because I'm using this quite often. But you can just search online or use Visual Studio to find out the name of the package and the version of the package. Because in my case, Visual Studio Code does not have that user interface to add and find these dependency packages. Now that we have that systemd package introduced, I can go back to my program.cs, and inside of here, I can add or use that systemd just like the use Windows service. You can also have both of them, use Windows service and use systemd, so that you can actually deploy your application to both environments, and then they have support for both. In this case, I only need systemd because I'm on Linux right now. And yeah, I can do the same as on Windows. I can do some command line utilities to install it as a service. One more additional thing I need to add in Linux is a little file called mylinuxdaemon.service. So in Linux, we need one specific file that describes my service. So this description basically is in configuration on what is the executable that I need to link to an actual service or a daemon. So in order to do that, I need to do this. I create a unit which has a description, which is my Linux daemon. Then I need to add a service, which is of type notify, and which has an executable start that actually points to the executable file on my disk. So actually, in order to do that, I'm just going to quickly see the bin debug net6. It should be here. Yes, my Linux daemon. So the executable start is on the root, then my home folder, then my username, then my sources directory, then my Linux daemon folder, bin debug net6, net 6.0, 6.0, and then my Linux daemon, the executable. Then I have the install part of this little file that says that it needs to be installed, wanted by a multi-user target. So this actually means that my service can run in a multi-user environment that doesn't specifically need a user interface, for example. So I save this file, and in order to make this work, I need to copy this file inside of the correct directory where systemd lives. So I'm going to use my terminal window to copy my Linux daemon.service file into that directory where systemd lives. So etc systemd/system. There we go. And then I need to call a command that reloads all of the current daemons for systemd. It needs to read all of those service files within that directory to make a new list of all of the daemons that are available. Now I can use this command status to look at the current status, and I can see that my Linux daemon service is inactive. And then I can use again that same command to, for example, start my daemon, start my service, start my worker app. And once it's started, I can again use that status command to actually see that now indeed my daemon is starting, but it's also running. So if you do this multiple times, you can actually see what it's doing. It's now sending those warning log messages and outputting the worker running at that specific time for each second. So that's how you install the same worker service as we did before on Windows on Linux, by creating that service file, copying that service file to the systemd directory, then reloading all of the daemons, and then starting your service and stopping your service whenever you want. And once again, we reached the end of this episode where I talked about worker services. I told you how to create worker services and how to install a worker service on a Windows or Linux operating system. In the next episode, I will talk about MAUI, or Multi-Target Application UI Platform, a technology we can use to create mobile applications from .NET. Did you like this video? Please give me a thumbs up, and if you wish to be notified of future videos, don't forget to subscribe to my channel, and I'll see you again next week.